to be remote, but he's not even on here. It's just gone. I hope he's okay. It's just because he was flying back from India. It seems to have gone bad.
Him taking notes, Krishna Swami.
Yeah.
And someone else you ask it.
Well, how does he needs to request? He needs to jump in the queue. Oh, where is he? Why can't I unmute his mic? Racco, I can't unmute Racco's mic. That's weird. Usually there used to be a knob to unmute the mic. Because he's asked you to check. Oh, okay. It's very quiet. I think we should start. Okay, good morning, everyone. Welcome to the BESS working group. I'm Matthew, and this is co-chair Jeffrey, and Stefan is unfortunately not able to make it today. And I think our secretary, Mankamana, is also not here. So as this is part of the IETF, it is covered by the notes well. Please do look through this and be aware of all of the implications of it and make sure that you are aware of them. I'll hold it up there for a second. So if you are here in person, please can you sign on to the session using Meet Echo. You can use the on-site tool via the QR code there if you just scan that with your phone. And for the remote participants, please unmute yourself only when allowed by the chairs to speak. We have a couple of note takers in the room. Thanks very much to them for volunteering or being volunteered. I just wanted to put this slide up first of all. We've been asked by the IAB just to highlight that there's a new work help desk. There was one on Monday and there's one tomorrow afternoon in the registration area. If you have some new work you want to bring to the IETF and you're not sure how to do it or where to take it or what the process is, please come along and the IAB will be happy to help direct your query. There might be some candy as well. Okay, agenda. We have a fairly surprisingly light agenda for BESS today. Any comments on the agenda? Nope. Okay, good. Okay, now on to the working group status update. So we're doing quite well. We had 4 new RFCs published since the last IETF. That's 9574, the optimized IR for EVPN, 9541, which is the CMAC flush draft, 9573 on EVPN, MVPN, EVPN tunnel aggregation with common labels, and 9572, which are some updates to the EVPN bum traffic procedures. We've got a couple of drafts in the RFC editor's queue. The EVPN for FDF draft is still held with a misref to the virtual Ethernet segment. And the EVPN IRB multicast draft. Okay, so thanks to Gunter for moving forward quite rapidly with processing some of the drafts that were in AD evaluation. There's 3 of them at the top there. I think that are showing revised ID needed. There was an AD review of those from Gunter. So if you have if there are any outstanding issues with any of those drafts, please respond on the list to that review and address those comments so that we can move forward as soon as possible. The extended mobility procedures for EVPN IRB is in Gunter's queue. The EVPN multi-homing extensions for split horizon filtering is in IESG review, which I think means it's gone past Gunter and it's now sitting waiting for broader IESG review. The fast recovery for EVPN DF election is in IETF last call. You can actually see a lot of this status on the data tracker. The data tracker is a fantastic tool for summarizing or tracking what's going on. We have a few documents and still under working group last call or in Shepherd's review. The multicast source redundancy in EVPN networks, I think it's waiting for Mankamana to do the write-up. I don't know if Mankamana has joined yet, if he has anything further to say for that. I think that's been waiting for some time. We will chase him about that. The weighted multipath procedures for EVPN multi-homing, it's got a lot of basically misrefs or normative dependencies to other documents that aren't ready yet. There's some comments from one of the IDR chairs, from Jeffrey, actually, about inconsistent or inappropriate use of ECMP. Do you want to say anything about that?
Actually, really just pending co-author's response and maybe action on that one.
Okay. Well, I think we're also requested a review from the IDR chairs. I'm not sure if hasn't been completed yet. The EVPN unequal load balancing draft. I think Stefan had requested a review. Yeah.
Chair swears he's done that. I can't find it. He's looking for his review. He said he did it 4 or 5 months ago. I'm still looking for it. I'll
Okay.
ping him again. While I'm up here, I might as well stay here and give you the other 2 requested drafts. So I'll wait while your slide flips. And
Yep.
I'm sorry, Sue Hare's IDR co-chair.
Okay.
Apologies.
The EVPN control point for Genève. So this went through working group last call a long time ago as a standards track document, but it was held because nobody declared any implementations, and we have a kind of a guideline that we need at least 1 implementation to progress a standards track document. Since there were no standards track, since there were no implementations declared for this, we kind of discussed this on the list, and it seems the best way to move this forward is experimental. There was also a routing director review of this. I think the authors have addressed all the comments now. So I'm just running currently a short working group last call just to reconfirm the change of status of the document, and then we will likely move that forward.
Do you want an IDR review of that one?
Okay. I don't think we need an
Underneath.
IDR review of this one.
Okay.
Do we? But the next one
I'm waiting.
was reviewed by IDR, the EVPN interworking with IPVPN. And
that one's in Jeffrey's hand, Jeffrey Haas's hands. He and Jorge are still, I know, discussing things, but I may be wrong.
I thought that had been resolved now.
Is it
okay,
resolved, Jorge? Yeah. Jorge says it's resolved.
Yes, that's my understanding as well.
If Jeff is happy, we're all happy. The other chairs haven't seen, I think, saw the result, but we'll double check for you. I thought it was good. Okay.
Okay.
Yeah, I just wanted to say that, well, we really appreciate Jeff's comments and the exchange. And yeah, we published the latest version. It's supposed to address all the comments. And actually, Jeff replied back saying that he was happy with it.
Good.
So we think it's ready to move forward.
Okay.
I think it's great.
Okay. Jeffrey, you're in the queue.
Yep, sorry I'm not in the room, but yes, the comments have all been successfully resolved. Thanks everybody for working on making this a better document.
Super. So I didn't miss that. I was waiting for the multicast ones that you asked for review. So I'll wait till just,
Okay.
shall I go sit down? No.
Um,
Okay, multicast controller is the one that I was waiting for, and then multicast.
okay.
Jeffrey, we need to talk on that one. Concepts are fine. I've read through the procedures pretty good. What you're missing in there is the details. Some more on the tunnel and caps. You're missing error handling and complete specifications of the parameters for the TLVs and a couple other things. I think a quick chat can give you everything you need to go work on. Then I'll review it again. CARES on the multicast draft, which it refers to. Usually we do a double review inside of IDR, but I can I can give you that one in my viewpoint today as well. Okay.
Great, thank you very much. I'll talk to you afterwards. Yeah.
Okay, apart from that, I think the other one of note on this slide is the 7432 BIS draft, which is being presented in this session. Okay, a few more. Yeah, it's the BGP multicast draft we just mentioned here. The EVPN MPLS seamless interop draft, which has had comments from the Routing Directorate and GenArt being addressed. And EVPN BFD, we think still needs a working group article jointly with the BFD working group. And I think we brought this up at the last IETF, and we'll progress this as and when we get to it in the queue. Okay, we have still a fairly lengthy adoption call queue. See which ones need to be mentioned. Want to make any comments on any of them?
Yeah, so the third and the fourth drafts in that list, the MVP and IPv6 infra and the CMcast enhancements drafts, those two, we have a comment there that they need to be considered together. Basically, the CMcast enhancement drafts includes a lot of scenarios. Some of the scenarios and problems and solutions overlap with the first one, the draft one. We had a lot of discussions on the email list. I believe the last email was from me stating that the solutions proposed in the CMcast enhancement drafts, the latest proposal addressed the problem and much better. We have not seen counter arguments on that yet. If we don't see further discussions on that, then we will, at least my personal as an individual contributor view is that we should go ahead with the proposal in the CMcast enhancement draft. And we also talk about folding those into that RFC 6514 BIS drafts. And we have not started that work yet, but the plan is to do that before the next IETF meeting. So the authors of the third draft there, draft one, please voice your opinion on the mailing list so that we can move this forward. At this time, my belief is that we should go with that, with the proposal in the CMcast enhancement draft. This is as an individual contributor.
Okay, so the draft presentations, I think first up is, okay. Oh, yeah. Yeah, wait, I've done that. Just a warning, if you're a presenter coming up here, there's a couple of things covering the cables at the front here, but I don't know, it might have been safer just to leave the cables there.
Yeah, and I'm especially clumsy. Do I get it? Okay, thank you. Slides look a bit. Okay, good morning. My name is Jorge Rabadan. Yeah, I'm presenting on behalf of my co-authors that you have here on the slide. This is the EVPN path draft 01. 3 parts of this presentation, a short refresh, changes that we've made since the working group adoption, and next steps. So a short refresh. So what we are doing in this draft is we take the DPath or the domain path attribute that was specified in the EVPN IPVPN interworking draft and that we just talked about a few minutes earlier. So we take that attribute and we use it now in this document in other EVPN routes. So originally in the when the DPath attribute was defined, it was only for inter-subnet routes, so layer 3 routes like EVPN route 5 or IPVPN routes. But here we are using it for EVPN layer 2 routes. And by that, I mean MAC IP routes, 80 per EVI routes for VPWS services, and also inclusive multicast routes. The main goal is to avoid loops on the data center, on the gateways, on the service gateways when you interconnect EVPN domains, and also to have better traceability and best path selection. In the examples that you have here is basically, very quickly, if you advertise a MAC IP route, for instance, if you look at the upper diagram, you advertise it, you receive it on gateway 1 and 2, and they exchange that MAC route between each other, and they add the DPath attribute with the identifier of the domain of origin. And based on that, they can, gateway 1 will identify the route as looped and will not redistribute the route back into the original domain. So that's for the loop protection. The same way that you have here for MAC IP routes, we can do it for 80 per EVI routes in the case of interconnecting domains for VPWS services. And you have another example here for traceability. But basically what that means is if you have redundant gateways and you get on gateway 3, if you look at the bottom diagram, you get MAC IP routes for the same MAC. Basically, you can, when you select, you do the selection to know which one to install. You can actually see the domain path attribute, and based on that, make a decision. You know exactly the domains through which the route has gone, and you can do best path selection. For MAC IP routes, you already mentioned some of this. Maybe something important to highlight is that this is completely compatible with the interconnect Ethernet segments in RFC 9014. So no matter what domain path attribute you receive on the routes, if they are coming with an ESI that you have locally configured, you're not going to redistribute the route back into the original domain. You can also use DPath for fast convergence in the sense that on the right-hand side of the slide, you have an example. Gateway 1, when it receives the route from Gateway 2, it will not install it. It will detect it as a looped route because it gets the route directly from PE1. But if for some reason that route from P1 disappears, it can now install the route and forward the in-flight packets to the other gateway. We can also use DPath for inclusive multicast routes. When you have gateways, typically you exchange IMET routes on the 2 domains, and they create parallel paths for bump traffic. So you really want to avoid that, and you can use DPath to select which one to pick. Okay, so changes we've made recently in this revision. So basically, there was an email exchange with Jeff. So thank you, Jeff, again for all your comments. So the first change that we made out of Jeff's feedback was about the DPath and best path selection for MAC IP routes. There are 2 rules in section 4.1 And the second rule basically was not clear. The second rule says that the routes with an numerically lowest leftmost domain ID are preferred, but we had to clarify what that meant, and that's what we did. The second change is basically we needed to add some warning text to basically bring awareness that if you have an inconsistent environment, if you have some gateways that are not upgraded and some others are, you may have inconsistent best path selection, which is not good. So that's why we added some text in section 4 and also in the security considerations section. It is worth noting that we believe, the authors believe that this is more controlled environment. It's not like in the layer 3 case where you can actually have attribute escape, and you can, you can actually send it to the seas and to the internet and all that. This is more for layer 2, which is always a more controlled walled garden, environment. So we, even though we don't think it's an issue, it's always good to add additional text to warn the reader. Another thing that we discussed with Jeff. I'm not sure if this is.
So not moving on.
Nope. Oh, there you go. Okay. Yeah. So what you have here is the best path selection. And this document is only modifying what we have in draft 7432 BESS. So it's only modifying and adding some extra rules based on DPath, right? But if you put together, for instance, for MAC IP routes, if you put together all the tiebreakers, this is what you have, the first bullet here. Of course, the 4 first routes, they only apply to MAC IP routes and not to AD privia routes or IMA routes, because they refer to extended communities that are only allowed with MAC IP routes. But the important thing is rule number 6 here says that the shortest DPath is preferred. So when you're comparing routes, and rule number 7 says that the lowest leftmost DPath domain ID is preferred, right? So we added the rule number 7 based on feedback that we received, that basically in this kind of environments, we needed something, more tools to influence the best path selection for these routes, right? That's the reason why it is here. So I just wanted to make sure that people reads and understands that this rule is also there. And other than that, please read and provide feedback so that the document can get ready for working group last call. Any questions?
Keyur Patel, Arcus. Two points. I think you are trying to avoid loop detections across the gateway, so that you want to carry essentially what layer 3 VPNs do with site of origin. Is that a good analogy? Because there is enough loop detection built inside BGP otherwise to track all the loops.
Yeah, so when you have redundant gateways in between EVPN domains, we want to avoid loop protection.
But you want to essentially carry some site information that says, hey, that's the PE who originated it, so that you're seeing the same route across.
Well, it's the gateways, when they re-advertise to an adjacent domain, they are adding this attribute with the identifier of the source domain.
That's what I meant, yeah. And that's very analogous to site of origin. Otherwise, you really don't need to carry this information. So I'm quite curious as to how you decided to come up with a new attribute while layer 3 VPNs have some ways of doing it. That's number one. And you can think about this and we can discuss offline, or you can send me something. I can send it on the mailing list. Okay. Number 2 is that, can you go back to that slide?
Which one?
The rules that you modified. Sorry, I know that's not working, and I apologize for making.
Which slide?
This one?
There. Stay there.
One more?
One more.
No.
Forward.
One.
The first one. The rules. I mean the last slide.
Yeah.
This is why the data tracker recommends that you number your slides.
Thank you.
Oh.
The second last slide.
The second last. Oh, okay. This one?
I think
Thank
so.
you. So what happens when you have two paths with one path that doesn't have a D path? Let's say the gateway stripped it off.
Mhm.
Does the rule set needs to be modified to say always choose a path with D path as opposed to a path without D path?
Yeah, so that's covered in the document. Basically, no DPath means the length is 0. So if you get one route with DPath and another one without, you pick the one without because the length is 0. So
Oh, wow.
You hit.
But that means if someone accidentally strips off D path, you have an issue.
Well, you change the best path selection, but you may or may not have an issue. Yeah, but yeah.
All I'm suggesting is you may want to think about that and always, because you've added a rule which probably makes a lot more sense that says, hey, choose the shortest D path.
Yeah, but I would also recommend you to look at the other draft, the original draft, which is the EVPN and PVPN interworking draft that we beat to death with Jeff and Sue, and we went through all these things, and sure, I mean there are rules for that, and we discussed all those things. But if you still think that there are considerations that we need to add to this draft, sure, let's discuss.
Thank you. I'll send it out to the list.
Okay. Jeff is next in the queue.
Yeah, thanks. So to respond to Kayer for the homework that he's missed, the motivation for things is not quite the same as site of origin for re-import to the originating site. Kayer, this is because this mechanism is used because things are going from one technology, L3VPN to EVPN, back and forth, and therefore you need the DPath to have the same behavior that a route reflector would put on with a cluster list. So this is solving the problem in a very clusterless-like fashion that would otherwise be lost. Site of origin is not sufficient for this. The length rules that you see here are very similar to the ones that we have for route reflection for exactly the same reason. And the cases you're concerned about are covered.
Yeah. Thank you.
Thank you. Next up, Alex.
Good morning. My name is Ali Sajasi, and I'm presenting a few drafts. The first one is this one, and I'm presenting on behalf of my co-author listed here. In this draft, basically, you guys are familiar with the secure EVPN draft, which talks about using BGP for point-to-multipoint signaling instead of IKV2, which is point-to-point, and the advantages for doing that. Do I have a?
Just trying to.
It's not working.
Give it a try. Let's see if it's working for me.
Oh, okay. All right. And the advantages for doing BGP, including the getting rid of the NS square issue and so forth. And it covers the encapsulation that is needed and gives an example what the encapsulation looks like for the VXLAN. And basically the format is what we have in here, that we have a IP followed by UDP, and the UDP points to the ESP header, says what follows is the ESP. And after the ESP, we have the encrypted IP packet, and VXLAN header is on top of that. So this is fine, but when we talk about high-speed switches that they need to do cut-through processing and keep their pipeline engaged, this raises an issue, and the issue is you need to go through the entire, you need to decrypt the entire packet, find at the ESP trailer, and then find out what is the next, find the next protocol field that points to the UDP header at the top, and find out how to process that packet. So basically, you need to do the entire decryption first in order to process the packet. And in the cut-through mode, that is not going to work, because cut-through needs to be able to process it one chunk at a time as it goes through the pipeline. So the proposal in here is basically to introduce a shim header right after the ESP header. You can think of it as a extended ESP header, but I didn't want it to call it extended ESP header to have issues with the IPsec-ME. This is just the shim header, follow the ESP, and we keep the ESP intact. And the UDP port, instead of saying this is ESP, what follows is a ESP, the UDP port number is going to say what follows is this ESP plus shim header. And in the shim header, we have the length and we have the protocol type. And so once the first segment of the IPsec gets decrypted, right then we have the protocol type, and we have the VXLAN header, and we can process the packet as it goes through the pipeline. And here it shows the format for the shim header, which is 8-byte shim header with the length field, 16-bit of length field and 16-bit of protocol type. So that is basically, in a nutshell, that what this cut-through frame format looks like. And we're going to be adding a tunnel type to the BGP signaling to indicate that this is going to be the ESP plus shim header frame format, and making sure that the PEs understand this, and if they don't understand it, that they don't need to process this. So that's it. This is not, is it out of battery or?
I don't know. Or we can, I'll just run the slides.
Okay, thank you.
This is Linda Dunbar from FutureWay. 2 comments.
Sure.
When you add something after ESP, yesterday I was at the IPsec-ME working group session. There was some proposal not similar as yours, but they are proposing adding something after the ESP header. And the feedback from that group was, why don't you request a new protocol code instead of ESP, maybe called ESP1, so make it easier for interoperability. That's just something maybe you can consider. Maybe send a presented over
we're
there.
I'm gonna solicit input from the IPsec-ME, but this is, we're keeping everything in the IPsec intact. And that's why I laid out that way, that you need just the shim header. And both the ESP and the shim is gonna be in open. I mean, it's not gonna get encrypted, and is not gonna impact any of the IPsec fidelity and procedure.
That's right. Yesterday there was similar discussion there. Just
Okay.
suggest you maybe discuss over there.
Right.
Second, in your draft, the section 4, entire section 4 on the SA key management, I feel that section to be taken out and be discussed at the IPsec ME, just for them to give some feedback on that. Just that particular section, section 4, because people here may not have the expertise on the key management.
The key, well, no, that we're going to keep it intact because it show, you know, it covers what we need. The key management and the rekeying, if you look at that section, is a function of the point-to-multipoint BGP signaling. So you cannot take it out and say, I'm going to discuss it separately because it is tied to that point-to-multipoint BGP signaling. So if you're talking about point-to-multipoint BGP signaling, the key management is for the point-to-multipoint BGP signaling. Otherwise, the key management for the point-to-point signaling is already covered in IQv2.
Well, yeah, I'm just suggesting you may present over there, get some feedback, and then just
as we move, exactly, as we progress it, we're gonna present it at the IPsec ME.
Okay.
But I'd like to keep the whole thing in one place.
Okay,
Thank you.
Just a reminder, if you're in a room and you want to go to the mic, if you can still get in the virtual queue using the on-site tool or Meet Echo, please.
All right, this is the second draft that I'm presenting on behalf of the co-authors. The apology in advance, this draft, I mean, this presentation is dry and doesn't have the nice figure that Jorge has in his slide. This is just the text. Okay. So the purpose of this presentation is basically to give you guys a heads up what clarification we've made to this document, given that this is a baseline EVPN document is important, and I felt it would be good to go over some of the clarification that we've done. And basically, you will see that this Rev 10 is in pretty good shape, and at the end of it, I'm requesting for a working group last call. So let's.
Oh, it works.
Yeah, it's on. It just needs a break in between. So the last time we gave an update was in March of last year, and we're going to be covering the changes since March of last year. So change number one is with respect to the multi-homing redundancy mode, and we use a single bit in a baseline RFC 7432, and in the BESS, we are using 2-bit because we have more than 2 multi-homing mode. We have all active, single active, single flow active, and port active. So we need more than 1 bit to present these 4 modes. We are using 2, and the document describes that, and we are we made sure it is backward compatible to the baseline RFC, but some places in the document, it referred to that single bit flag, even though we defined the 2-bit flag. And credit to Sasha, he caught it and he brought it to our attention, and we update the document to address that. Seems like Sasha, as soon as I called his name, he went to the queue. So should I just stop and see what comment he has?
Yes, well, it's up to you, but yeah.
Yeah, that's fine. Sasha, go ahead.
Sasha Weinstein, it is not a comment on the draft. It is just that port active mode is not signaled via the multi-homing redundancy mode isn't signaled via this field. This field indicates, according to the draft, single active, and the port active mode is signaled in the DF election extended community that is attached to type 4 out.
Okay.
So you don't need four, as of this
So, but this
moment,
is,
there are
the-
just three, you need just three values. With 2 bits, it seems to be sufficient.
so it used to be 1 bit and we changed it to 2 bits to make it sufficient.
That was fine. What I'm saying that you have mentioned port active, it is not relevant for this field.
Okay, all right. Okay, the next change, port-based service interface and the treatment of the untagged user data traffic. This is again clarification. Basically, in 432 bits, it doesn't explicitly talk about how you're going to treat the untagged user data traffic for the port-based interface. And again, Sasha brought that to our attention that we don't have an explicit mention in here. And even though it is implicitly understood how to do it, I felt that it is a good idea to add a couple of sentences to cover this. And so we added a couple of sentences to the section 621 and 631. And section 621 is a port-based mode under VLAN bundle service interface. And with the VLAN bundle service interface, you have only a single bridge domain, and you map all your VLAN and traffic from that port into that one bridge domain or bridge table. And for untagged data, untagged user data traffic is no exception, and we map it to the same bridge table. And then for the section 631 is VLAN aware bundle service, where we have a bridge domain or a bridge table for each VLAN. And untagged traffic also gets its own VLAN bridge table, and it gets mapped to that. So we added these couple of sentences to clarify how we do the untagged user data traffic treatment, so there is no ambiguity. Go ahead.
The addition, what you write here about section 621 is fine, of course. Regarding section 631, I have some doubts because normally the handling of untagged traffic in the IEEE standards suggests that they are added to this, such traffic is supposed to be added to the same table, a bridge table, as defined by the port-based VLAN for the port from which it is received. So I'm not sure you need an additional bridge table.
So we have an additional for the port mode in this.
Yeah, but
it depends how you want to define that port mode, okay? You can just simply say port mode is only for the, it means I don't have any visibility to the VLANs and I'm transparent to the VLAN, and that becomes 621. You don't need to do anything beyond 621.
No problem with 621, okay. It's just 631.
Then for 631, you want to, there is another school of thought says that I want to be VLAN aware, and I'm gonna say all the VLANs, okay, for that port, I want to be able to treat it separately.
But there is also, again, my question is, there is a port-based VLAN for the port, and IEEE rules say that untagged traffic is treated as if it were tagged with the port-based VLAN. So I'm not sure this is...
This is consistent with that, because in IEEE, we use the default VLAN for untagged traffic. Default VLAN. Everything that goes untagged goes into the default. This is the same thing.
But it is not, which means that it is not an additional bridge table. It is the same bridge table.
No, it is an additional, because the default VLAN is its own VLAN. has its own bridge
Yeah,
table.
but if you receive, let me ask it like this. If you receive two frames, one which is untagged in the case of a port-based
Right.
service, one frame is untagged and the other frame is tagged with the port-based VLAN. Should you send them to the same bridge table or to two different bridge tables?
So typically, you don't get for the default
No.
VLAN, you don't get the tag traffic which has a default VLAN. Okay,
t-
so you get two VLAN, you get the two frames, one with the VLAN 100,
Yeah.
one untagged. They go
no,
to
no,
two bridge
that,
tables.
that's fine. This is fully okay.
So what I want to avoid is going to the rat hole and explain hypothetical situation.
Okay.
I try to clarify it without going off tangent and try to do a tutorial on IEEE default VLAN and all that, okay? And this is basically the most concise way to do it. And I think this is understood, okay?
Okay, let's take it offline.
Okay.
Because I must check what I'm saying with my book. Look up the article.
Okay.
Okay.
So what is captured, just briefly, what is captured here is correct because it says it gets its own, the default VLAN gets its own table, and that we know that's the case. It gets its own table. It doesn't use any other table from the other VLANs. Next slide, please. Okay, change number 3, originating router IP address. This came up as a result of doing some interoperability testing for the V4 to V6 migration, and some people thought that originating router IP address has to be of the same type as next hop IP address type. And we've added this clarification that no, that's not the case. That doesn't need to be the case. They can be two different because one is used, originating router IP address is used to identify the source of the originating node, the identity of the originating node or source node. And the next hop is used for forwarding. So they don't have to be of the same type. Change number 4, for the signaling of the primary and backup DF elected PEs in section 8.6, we just made it modified to make it more concise. So we went from what you see in the first paragraph into the second one, that as you can see, it carries the same meaning, but it is more concise. So again, it's done to tidy up the text in the draft and make it more clear. Number 5, what? Okay. You're doing it for me? Thank you. Change number 5, MAC address aliasing in section 10.1. We just simply removed the paragraph which we felt it was not being used, and so wanted to make sure that doesn't create any confusion. So we just simply removed the paragraph. Okay, next one, please. P-tunnel identification, we added that clarification to make sure that, you know, in case of the option B and propagating the IMET route for inter-AS option B, it is clear that what what field should be used to resolve the route to the LSP, and that is the BGP next hop of the NRI attribute and not the IP address in the tunnel attribute. Next one, please. Section 7 covers a sticky MAC, and we added a couple of paragraphs to describe the IRB, the MAC address associated with the IRB interface is a sticky MAC, and when we advertise it, we can advertise it with that flag set to make sure that it is clear that when the IRB MAC is advertised, the receiver know that mobility for that MAC is not valid, and they can take proper action. Next slide. Loop protection, we again, this is a clarification that instead of black hole MAC, we change it to drop MAC and explain for the to catch the loop and for to catch the duplicate packet when we flag a MAC for the drop as a drop MAC. What the procedure we're going to take, how we're going to handle it, how we're going to increase the counter. We can associate or maintain a counter for this, and how to do it. So just a clarification on that front. Next slide, please. And then frame ordering. Again, there was some discussion, lengthy discussion on the mailing list that we have to use the control word in all instances, including the entropy label. And I just wanted to clarify that when we talk about if a network uses entropy label, then the control, when we say control word may not be used, that by network we mean inclusive of all PE and P nodes. So we clarify that text so we don't come back and say, oh, there are some nodes in there that cannot handle entropy and so forth.
So just chair's hat off on that. I think the issue with the wording is that you can't detect that all, you can't detect that case. That's the problem. You don't know all of them support entropy label or not.
Well, the operator either gonna go and enable the entropy, and if it enable the entropy, they can check whether all their network can handle it or not. And if the if the operator doesn't have that capability, then yes. But if it does, and if we are saying that if the whole network is capable, then the control word is optional. And if you can see, we watered down the language saying control word may not be used. Okay, we change it from should to may to water it down.
The lowercase may not, does not sound right though.
Pardon me?
The lowercase may not, does not sound right here.
Okay, maybe we change it to uppercase may. Okay, next. Like some time back, we addressed, I think maybe a year ago, or 6 months to a year ago, we addressed the comments from Mike McBridge on behalf of the RT director and Stuart Bryan on behalf of Genart. That was 6 to 9 months, and we have revised the draft since then a few times for additional clarification. I think we are good to go with the working group last call on this one. So I would like to request to be placed on the queue for that.
Okay, well, we'll put it on the queue.
Yeah, okay.
Okay, there are a couple of people on the queue, in the queue, so.
So go on. Go ahead.
Yeah, sure. I just had a quick question. Is there I think maybe a good idea just from like the original RFC 7432 and the BIS, maybe a change log of what all the changes, maybe just a brief section. I think that would probably be helpful. Also, since RFC 7432 came out, there have been quite a number of new route types, and they're all spread across many different RFCs or drafts. I wonder if a lot of that would be incorporated into the BIS. Thank you.
I couldn't quite hear.
Yeah, your mic is very muffled. Go on.
Sorry, let me, all right, hold on.
I'm sorry, I couldn't quite hear you clearly.
Okay, can you hear me now? Is that better?
That's a little better.
Okay, sorry. So let me just repeat that. What I was saying was the original EVP, the original RFC 7432 RFC, there was a base set of route types, but since it came out, there were a lot of new route types. So I wonder, would all the route types that have been added since the base RFC, would they be included in the BIS draft?
No, because all those route types has already gone through they're being registered as part of the INR, and they're being described in their corresponding drafts. So there is no point in the list all the routes in here if you're not covering them. If you're gonna include all those route types, then we need to include the procedures for it, and that means now we have to consolidate tons of draft together, which is not the intention in here.
I see. All right, thank you. And just one last comment is is there a change, maybe a change log that kind of has changes from the original to this draft, that it kind of lists like all the changes? That would be helpful.
So we kept a log of the changes, and I think we moved it to appendix, and then.
Oh, okay.
But it's gonna get stripped out once we go into the
production.
Once it becomes an RFC.
Understood. Thank you.
Sure.
Thank you.
Okay, I think.
Okay, and any other questions? Okay, I think it's Ratko now, but I don't know. Is your audio working, Ratko?
There's another one.
Oh, sorry.
Oh, I have.
Okay, so you got past that. Okay, good. Ali, go ahead.
All right, the final draft that I'm presenting is for the fabric migration, V4 to V6, or maybe V6 to V4. Okay, problem statement is basically to be able to migrate the EVPN fabric. And what we mean by the fabric, we are talking about underlay network. We know that EVPN, for the overlay, it handles both V4 and V6 right from day one. So it is an underlay that we are talking in here. And we want to do that seamlessly. And the keyword is seamlessly. Be able to perform these migrations seamlessly for any type of the EVPN multi-homing operation, and to have that migration to be independent of the BGP control plane session. So we don't have to upgrade the control plane session in order to migrate the data plane to the V6. And we want to also be able to revert either during this process or at the end of the process. Basically, to do that, we are saying that we need to enable the dual stack in the underlay, and both PE and P nodes needs to support the V4, V6 dual stack. And we want to continue using the next hop field to carry the primary IP address and then the secondary IP address gets sent in the BGP tunnel encap attribute. And so when we talk about V4 to V6 migration, the next hop is going to be V4, and the tunnel encap attribute is going to carry the V6 IP address. So the procedures, although it is, we enumerated a bunch of steps, I think it is pretty straightforward. Initially, we start with the single stack mode, and the VXLAN encap is IPv4, and we upgrade the underlay network protocol, either IGP or BGP, to dual stack to provide both V4 and V6 connectivity. And then we upgrade the EVPN VXLAN encap for the first VTEP to dual stack. So we configure the next, we configure the both, we configure V6 IP address in addition to the V4 for EVPN VXLAN operation. And once we do that, then the VTEP 1 or PE1 advertises is EVPN routes with V6, with this secondary V6 address. And the secondary V6 address gets advertised in the BGP tunnel encap attribute. And the other guys receive it, and the other guys, you know, if they're still operating in the V4, if other VTEP, they don't know what to do with these optional secondary address, and they don't do anything till you go and configure the second VTEP. And when you configure a second VTEP for this operation and you advertise the secondary V6 IP address, then VTEP 1 will receive it along with all other VTEPs, but VTEP 1 is the one that is configured for this dual mode operation. And the preference is when you receive both V4 and V6, you use V6 for the encapsulation. So VTEP 1 is going to use V6 for the encap, and VTEP 2 also same thing. So as you can see, as you upgrade each VTEP node to dual stack operation, more and more of these guys, of these PEs, going to join the V6 party, and they're going to be using V6 for the encapsulation. And once everything has been converted, then you can upgrade the BGP session from V4 to V6. And once the BGP session is upgraded and you want to just go to the single stack, then you deconfigure V4, and then the routes gets advertised with the V6 next hop. So that's basically in a nutshell. And there is a diagram that describes this. And there is a, so under the BGP procedure, we are talking about to use this BGP tunnel encap attribute for the advertising the secondary IP address. And we explained in that we don't need to carry the encapsulation sub-TLV of that attribute, even though RFC 9012 says you should carry it. We don't need to carry it is because the information associated with that sub-TLV already is carried in EVPN route. And we're going to keep it consistent, and we're going to be using BGP encapsulation extended community per RFC 8365 to indicate that this is a VXLAN tunnel type. Originating router IP address, we explained in that draft again that this is intended for just identifying the originating PE and not used for forwarding. As such, they don't have to be the same type as the VTEP IP address. The multi-homing operation, also we describe it in the multi-homing operation that you don't have to upgrade both of if you're talking about dual homing, you don't have to upgrade both PEs simultaneously. You can still upgrade one PE and the multi-homing still works. And the way it happens is one PE advertises it with the dual routes, the other PE, other multi-homing with a single route, and the remote PE that receives it and it builds is adjacency tables for the ECMP operation. In that adjacency table, it uses V6 for the guy who has upgraded, and it uses V4 for the other multi-homing PE that hasn't been upgraded. So it would work, the ECMP and all that. And we are soliciting input from the working group, and that's it. So we have a few people in the queue.
Thank you for your presentation, Ali. This
Sure.
is Sue Hares. In this hat, IDR Chair.
Right.
Could you go back to the discussion on the tunneling caps? And no, that you had the right one,
Oh,
where it talks about, go on, there, that one, please stay, thank you.
sure.
Would you go through your reasoning on why you're breaking RFC 9012? Because it explicitly denied this case for good reasons in the review. So can you explain why you think you should ignore it?
So I don't think we are breaking anything on the 9012. RFC 9012 itself says for the EVPN, we can use BGP encapsulation extended community.
Yes, the BGP
Okay.
encapsulation you have there
Right. And
has, okay, I'll ask my next question when it's my turn.
then, right.
So it has a flag for the tunnel, and then it assumes the address is from the next stop in the packet. How can you have a second address there? I'm confused on what you're trying to do.
So there is the second address that we are talking about. We are talking about the second address type. So the first address is carried in the BGP Next hub.
That's right.
Okay.
We both agreed on that.
For the NLRI, okay? Now I want to carry the second address for the V6. BGP Next hub for the NLRI doesn't allow that. There can be only a single BGP Next hub. You cannot have two. And then the other option is BGP. The other option is the BGP Next hub attribute, not the BGP Next hub field of the NRI attribute, but BGP Next hub attribute. And that attribute only supports IPv4 and not IPv6. So then the third choice, which is reasonable, is to use the attribute that allows for that. And we are basically consistent. In other words, if we were only going to use V6, okay, we could have used this tunnel encap attribute for the V6. And we are saying that We are doing that in adherence to 9012, but 9012 says here, besides carrying the tunnel IP address, here are all the fields for the VXLAN encapsulation. Okay, if the tunnel type is VXLAN, here are the fields. And it doesn't say you have to use this sub TLV. Okay. All I'm saying is we don't need these sub TLV.
So let me reset this because I think we're not talking about the same thing. I was asking about the one specific case of BGP encapsulation extended community. Are you putting a second address in that extended?
No, absolutely not. The extended community is only 6 byte, so we are not putting a second
so you're
address in there.
not putting a second. That was my question,
Okay.
not the other part, just that one.
Okay,
Okay, thank you for clarifying.
sure, you're welcome.
Jorge Nokia. Yeah, thanks for this, Ali. Yeah, I think it's a good solution for the seamless migration. My only comment is you had a slide that talked about the originating IP address,
Right.
saying that it really can match or not match the next hop because it's not used for forwarding. I agree with that statement, but it has implications on the DF election for multi-homing, right? And in two ways. So the first one is for DF election, we use the originating IP of the ES route for the candidate list, right? So if you change it to an IPv6 or not, you may change the order.
Okay, I am very glad you brought up this point because that point has already been captured in the RFC 7432 BIS. In the 7432 BIS, there is a text that covers what happens when some of the PEs in the multi-homing are IPv4 and some are IPv6. And in that case, we are creating an order list, okay? And the order list that we create is basically with the V6 addresses always, because they are bigger field, they always comes after V4. So everybody can consistently build that order list.
No, I know everyone will build the candidate list. What I mean is, if you change that IP from a V4 to a V6, that changes the order of the PE itself. So what I'm saying is that there is nothing wrong with it.
Impacts the DF election.
But it has to be reflected somehow.
Oh yeah.
And the other comment is.
So that's a good point. That okay.
Yeah, the other thing is in RFC 8584, we have this IETF influence DF election, which is a capability. You can prune the candidate list based on the reception of the 80 routes. But the 80 routes can only be identified based on the next hop, as you know. So if you use in the ES route, you use a V4 address, and the 80 routes you use a V6 address. There's no way you can correlate them together, right? So that has to be reflected as well in the draft.
Yeah, that's a good point. So if you can, send the email with respect to these 2 points.
Yeah, I'll send you my comments for sure.
Thank you.
Thank you.
Sasha Weinstein, first of all, I have to admit that I didn't read the draft, but from what I have heard here, I have a question.
Okay.
EVPN VXLAN may be used with assisted or optimized ingress replication. And assisted ingress replication relies on the source IP addresses in the IP headers of outer IP headers of the VXLAN encapsulation for replication purposes. From what I have heard, it seems that the draft simply doesn't say anything about what should be done in the migration process if assisted ingress replication is used.
So that's a good point. I mean, the draft at this point is basically for ingress replication.
Yeah,
okay, at this point, okay?
Yeah.
But not just assisted replication, but also there is implication on point to multi-point, okay? Because now you need to set up another point to multi-point tree for the, you cannot use the previous tree, which is V4. So both of these needs to be addressed. So not just assisted tree, but if you can also mention the point to multi-point tree, send me an email on that and I'll try to cover it. But we need to cover that. Thank you. We got anybody else is on the queue, in the queue, or this is?
Quite a few.
We've got quite a few. We've actually capped it after John. Just if you could keep your comments brief, that would really help. Thanks.
Rashad Equinix, I've got a very basic question and read the draft. It says VXLAN. Does that mean that the solution works only for VXLAN, or can it work for other encapsulation types?
So the primary use case was VXLAN, but it should be applied to other tunnel encap, MPLS, and other IP, other encapsulation over IPv6.
Okay, thank you.
Sure.
When?
Hi, Ari. Thank you for the presentation. I have share the same comment Jorge brought up. It probably won't be a problem for people using IPv4 to start with as a router originating router's IP address, but since it's allowed to using IPv6 for underlay IPv6, so this is a change from V4 to V6. So need to address the seamless part.
When can you please repeat it again?
My comments is similar to Jorge regarding the originate router's IP address. Right now, the 7432 bits has a clarification to say this can be either a V4 or V6 IP address if underlay is IPv6. So this draft for the seamless part need to address if the people using IPv6 using underlay. For IPv6 underlay case, the originating router's IP address using IPv6 and the V4 using V4. So this actually triggered the router change, because this is a part of router NNI and also the ordinal list.
So I'm not quite sure what you're asking.
I'm asking to address the seamless part when the router's original router's IP address got changed.
Okay. Yeah. The seamless. Okay. So Jorge comment was in context of clarification for the general DF election, and then one for the other one for the AC DF election. And,
DF election is part of it. Yeah.
So, so is your comment also with respect to the DF election or something else?
There's two parts. One is a DF election, right? So the sequence got changed, and the other to have a paragraph touch base on the seamless part, because originating router's IP address is part of key for certain route type, EVPN routes. So we will get a new routes will get advertised to see if there are any issues with the seamless.
Okay.
Yeah,
so it should, in terms of, we can have an offline discussion to see what the issue, if any, you're concerned about. But the whole idea to keep the originating router IP address is to enforce these seamless operations. So in the middle of the process, you don't end up with different routes. Because if you modify the originating router IP address, basically, in effect, you're going to have a different BGP routes. So that's why in the draft, it says you keep it the same during the process, during the whole process. You keep the originating router IP address the same.
Yeah, when you change from V4 to V6, if the migration is from V4 to V6.
And if once the migration is, everything is complete, okay, and you're going to the single stack, if you're still in the dual stack mode, you keep it the same. If you're going from dual stack to the single stack, then at that time you can change it if you want.
Yeah, we can talk offline. I'm
Okay,
talking the
sounds good.
scenario, yeah, from single stack to single stack.
Okay.
That's from V4 to V6.
Okay.
Thank you.
Thanks.
Hi,
John,
thanks.
go ahead.
Thank you. This is kind of a repeat of something I said in the chat. About your use of RFC 9012, I know you said that you're in adherence to 9012, but it really doesn't kind of smell that way to me. Like 9012 has a whole bunch of semantics defined with it, and it kind of looks like you just took a look at the attribute and you said, hey, there's a thing shaped like an IPv6 address in there. I'll just take that one and I'll leave everything else on the tree and not take that, which doesn't seem like really a very interoperable or clean way to do it. It's like all you need is a way to communicate an IPv6 address. It's probably cleaner to pick something that doesn't have existing defined semantics. Or if you want to use 9012, it seems like it would probably be cleaner to use the whole thing and say, I have a way to communicate it in caps here, in one place and do that. We probably can discuss it further offline because I think we're not going to be able to work through the whole thing at the mic, but I wanted to get that comment in.
All right, sounds good. I'll double check on that.
Kirk, you can go ahead, but be quick.
Thank you, Chair. I know the queue was close. Kirk Patel Arcus. Hey, just stretching Jorge's point a little bit. If you're going to put in the procedures, you are going to make sure something along make before break, meaning announce the new next stop, withdraw the old next stop, correct?
Right.
All right, thank you.
All right. Good, the whole agenda was light, or else we would have gone over our time budget. All right, thank you very much.
Okay. So we've run out all the buffered time we have. So for the rest of the agenda, we'll have to watch the time very carefully.
Okay, so next, I think, is Ratko, but I don't know if your audio is working. If you can just unmute yourself, see if that works. If not, we'll have to skip over it. I do not hear anything. Okay, I'd suggest you basically send a summary to the list of what you're going to present. So we've got, on next.
Okay. Hi, everyone. I'm Yao from ZT, and this draft is about data plane failure detection mechanisms for EVPN and PVP EVPN over SRv6. Next, please. So for data plane failure detection in MPLS EVPN, BESS has IFC 9489, which leverages MPLS as a BPM mechanism. And some new target RFC stack subTLVs are defined for the corresponding EVPN scenario. And the MPLS echo request is sent from ingress PE to egress PE. And the egress PE validates the EVPN related info in FVC subTLVs and then sends the results of the validation in an echo reply. And when it comes to SRv6 EVPN, which already has many implementations, the requirement for data plane failure detection is similar to MPLS EVPN, but there's no standard mechanism in SRv6 for this requirement. Next, please. So the basic idea is define two new types of ICMPv6 messages separately for the request and the reply, and using the ICMP extension structure. In the validation request, the validation objects are included to carry the information to be checked. And in the validation reply, the code field indicates the validation result. Next, please. So following are the structures of some object payloads defined for SRv6 CVPN. Based on the consideration that the encoding of SRv6 CVPN routes are similar to those in MPR CVPN. So all the objects are defined taking examples by FEC subtier Vs for MPR CVPN in SVP. And the first is the MAC IP object. It identifies the target MAC and MAC IP binding for ARP OND or IP address for an EVI under test at an egress PE. I'm sorry. Next, please. So this is the EVP Ethernet AD object. It is defined based on the EVP Ethernet AD route advertisement. Next, please. And this is the EVP IP prefix object. It identifies the IP prefix for an EVI under test at a peer PE. Next, please. So here's the main processing procedure. So sending a validation request is kind of like pinging an SRv6 seed. So one of the objects defined in the previous slides are carried in the new ICMPv6 request, and the related SRv6 service seed for EPN route is set as the last segment with SRH. And if the SRv6 service seed is globally reachable, you can send without SRH. And after the egress PE receives the validation request and finds that it is the generating node of the service seed, and the egress PE will verify the information encoded in the request message against the local information and forms a validation reply with a return code set based on the validation result. Next, please. So here is an example for connectivity check in PVP EVPN network. In this network, C1 is dual homed to P1 and P2, and P1 and P2 both announced MAC route with different SRv6 services. So on P3, an operator performs a connectivity check for the BMAC1 on P1, and the validation request packet is sent to P1 with SRv6 service 1 and carrying RD1 and BMAC1 in the EVPN MAC IP object. Then the P1 checks the connectivity for BMAC1 and returns ICMPv6 validation reply with a code indicating the validation result. Next, please. So about the next steps, the multicast connectivity validation will be covered in the future version. The question is, do you have similar requirements in your network? And actually, besides this draft, we have another draft, kind of like a base draft, which aims to provide a general mechanism to validate different kinds of SRv6 said related informations. But we want to find some more specific and strong use cases. And thanks to Matthew during last IETF, mentioning the work in BESS or MPS EVPN connectivity check. So we write this draft dedicatedly for SRv6 CVPN based on the similar scenario and requirements. So you can check both drafts if you are interested, and welcome feedback, comments, and cooperation. Thank you.
Hi, my name is Zafar Ali from Cisco. I worked on the base SRv6 ONN and 6-man. There are actually two aspects that are covered in this draft. One aspect is the technology-specific encoding, which is really the best. But there's another aspect where the verification and response messages are defined, and those are the base ICMP messages. And that work, it needs to be done in 6-man or interior. That's one comment that I'd like to make.
Oh, thanks, Safa. Yeah, sure. So, why we first why we want to present this on BESS and other related working groups, because first we want to find some use cases. So we actually want to introduce some LSP-like structure for SRv6. So if these requirements are agreed on, for example, on BESS, so then we can go to 6-man for the detail, for the extending details. So on how we can do this. So yeah.
Jorge from Nokia. Thanks for the presentation. I have no comments about the procedures, but something that called my attention is that you are talking about PBB EVPN. So in RFC 9252 actually does not specify PBB EVPN extensions for SRv6. So to me, it's really not specified anywhere. So I'm surprised that you are talking about PBB EVPN over SRv6. Do you have any comments about it?
Oh, so I'll go double check about that PBP part. So maybe I write a wrong example. So in our draft, we have the EVP connectivity part. So I double check if it's not right. I'll leave out the PBP part. Thank you.
Okay, Alice, maybe I can answer Jorge's question. I think the reason PBB VPN is mentioned here is because this draft is written based on RFC 9489, and which is MPLS based, and MPLS covers both EVPN and PBB EVPN, and then that's where the PBB EVPN got into SRv6, which it shouldn't, okay, which it shouldn't. But my comments is basically following what Zafar mentioned earlier. The way I look at it, there are two parts. One is with respect to this OEM verification, one is the container, and then one is the context of that container, okay? The container, in case of the MPLS transport, we have echo request and echo response. In case of the IPv6 or SRv6, we have validation request and validation response and so forth. And the container needs to be there, but that's very small portion. That's like I would say 5% of the, if you want to write a draft, that's 5% of it. 95% is the contents of that container, which is being defined in the RFC 9489. And I would say that that context, unless somebody comes and says, we need, this sub-TLV and these contents that are defined in that RFC is not applicable to SRv6 or is not applicable to VXLAN or whatever. If somebody cannot just say that, then we should keep it in one place. And we should basically have a small section to cover different transport. One transport is already covered is MPLS. The second transport can be SRv6. The third transport that is needed is VXLAN. We need to have this procedure for VXLAN as well. So I would like to keep the whole thing in one place. Maybe we write a errata that we need to cover it for RFC 9489 needs to cover other transport, and then extend that RFC with a small section for this transport. But as we talked, that for the IPv6 transport, we need the work first to be done for the ICMP. So that needs to be done. Once that is done, extending, putting the context and putting this sub-TLV in it, that I think is a cookie cutter. So that's my comment. Thank you.
Thanks. Okay, I think you're up.
So it works. Okay, Jorge Roa then. So this draft is basically about an issue that we found in RFC 9251, and yeah, we wanted to bring awareness. I don't know how serious the issue is, but at least it deserves people's attention. I'm going to talk about the issue itself, potential solutions, and next steps. So the specific issue that we found in RFC 9251 is the procedures with the multicast leave procedure itself. So RFC 9251 basically solves the issue of synchronizing the leave state when you have multi-homing, in 2 or more PEs. So what you have at the upper part of the slide is the issue itself. It's basically a short refresh of the issue is if you have a CE that is attached to this all active multi-homing Ethernet segment and the non-DF is PE1, it may send a leave message to PE2. PE2 initiates the maximum response time procedures and all that. It sends the last member query. But the response to that last member query can actually be hashed to the other PE, to PE1. And if that happens, basically PE2 will never realize there is still interest on that multicast group. So RFC 9251 resolves the issue, but adding a new EVPN route type, which is type 8. And basically in the same situation, if you look at the bottom side of the slide, when we receive the leave on PE2, now we also advertise this route type 8, which includes this maximum response time. And upon receiving the route, PE1 basically installs the route and takes that maximum response time and starts its own time for the leave procedure. So if it receives that join in step number 4, if it receives that join before the timer expires, basically it sends a multicast report sync route, and PE2 will know that there is still interest. Okay, so that's the whole thing. So what is the issue here? The issue is really 3 issues. Let's put it this way. The first one is there are different interpretations of what the max response time encoded in the route is, right? So if you look at section 6.2, at least for us, it's not clear what that maximum response time is in the route. Could be the last member query interval times last member query count, or it might be the maximum response time, which is matching the group-specific queries, the specific field itself. So our interpretation when we implemented this is that it is actually the last member query interval times last member query count. But maybe you have a different interpretation, so it would be nice to discuss it. The second issue is, there are some cases where you cannot encode, so the protocols, IGMP, V2, V3, MLD, V2, they actually can support values for this maximum response time that are actually larger than what you can encode in the route itself, right? And that is specifically an issue on IGMP v3 or MLD v2, where the actual max response time in the queries, it comes with a floating point format, so you can actually have exponential values, and it can go really, really high. So, and those values, you cannot encode them into the max response time in the route type 8. So the question is, what do you do if if someone configures really, really large values, right? So we need to somehow say what to do. And the third issue is the RFC talks about this delta time that PE2 needs to account when it starts the timer, the local timer, basically to compute also the time that it gets for the leaf route to get to the other PEs in the Ethernet segment, the BGP propagation time, right? That is sometimes not easy if you configure it manually, it's not easy to figure out how long that timer has to be, right? So, and that may lead to premature removal of state and churn. So we have those two issues. There are different ways to address them, but basically what we want is to address them somewhere and somehow. For issue number 1 and 2, we need to say what happens, what exactly we encode in route type 8, and if we have a larger value in the local protocol, we need to say what to do, right? The draft talks about some potential solutions for that. The solution for issue number 3 is we can actually, instead of configuring the delta time for the BGP propagation, we could actually use this timestamp extended community that we are already using in the fast DF recovery draft. And if you add that timestamping to the route, you don't really need to configure any fixed, time or extra delta time. So we're discussing with the RFC 9251 authors and Jeffrey as well. We had some discussions, and there are different ways to fix this. So one way is to keep with this short draft, and that we can, it can end up updating RFC 9251. Another way is to create a BESS draft for the RFC 9251. We are really open to, to discuss the different options. So please read the draft and provide feedback about what existing implementations do. And based on that, we can continue the discussions with the co-authors and see how we address this. Okay, questions? Yeah.
I think Mankamana was first, but I can go if you're okay.
Yeah, go ahead, Ali.
Okay. First, Jorge, thank you for this draft. I think we need these things to be addressed in order for the interoperability to work. So thank you for that.
Thanks.
And these needs to be addressed. Question, as you mentioned, where to address it. And my take on it is if the changes are small, then it makes sense to incorporate it into the 9251 BESS. But if the changes are significant and big and we have to write multiple pages, then it justifies its own draft. So thank you.
Okay, thanks.
Mankamana?
Yes. So I think so there are two parts, what the solution could be, and the second part is how exactly we are going to.
Sorry, can you speak closer to the mic? I can't hear you.
Oh, you can't hear me?
Not very loudly.
Just give me a second.
Are you still there?
Yes, I'm there. I'm just trying to fix my mic.
Okay, just go ahead and we'll see.
We'll see.
Okay, so the first part is what exactly the solution which we are going to use. And one of the point, if we look at maximum response time, I think when the IGMP original RFC was defined, it was mainly for land kind of situation. This involves a lot of timers. I think I did speak to Jorge that can we do in a way where both of the peer, they actually configure manually, and we don't really rely on all these mechanism of transport time, because it is going to add extra overhead with respect to implementation. When I say overhead, it is complexity. And as he pointed out, depending on how long BGP is taking to deliver these routes, the leaf sync route, there are chances where either we may premature delete something, or maybe we will have extra traffic. So that is one point to consider. I'll definitely send it mail over for the working group as well, so that other people can chime in and see that what kind of solution we would like to do before we decide on how to do, whether it is new draft or this.
Okay, sounds good. Thank you.
I want to add that I've learned the one implementation, it actually does not use the maximum response time in the message. It just simply do a last member query on its own.
Okay.
Yes, that's how our implementation is as well.
Okay. Thank you. Guyan, I think you're up. You can share the slides.
Hi, everyone. Can you hear me?
Yes.
Okay. Hi, my name is Gyan Mishra, and I'm presenting this draft IPv4, IPv6 only P design, all SAFI, on behalf of my co-authors. Next slide. Next slide. Thanks. Sorry, the one before that. Okay. So just a few updates I wanted to give today. So I have added a section on SRv6. So that's this SRv6 compression, CFIT applicability to the VPN overlay stitching. So applicability of that to this draft. So a section on that. I've also added, so there was a discussion on mailing list, on the BESS mailing list that Jorge had sent, and it was a really interesting thread that started, but it was related to adding support for type SAFI for the BGP Yang model, which is in there, and then how to do that. So when that was brought up, I actually started to research that, just the idea of type SAFIs versus non-type SAFIs, and then the applicability of type SAFI. So with this draft, all SAFIs are supported, and that's what I kind of have in this draft to support, but there are some caveats with certain SAFIs. So type SAFIs, they're actually, from researching this, they appear to be not applicable. And then I have a slide that kind of goes into that. So also I have an update on testing. So Juniper and Nokia, so we were 100% completed all testing. So that's a really huge landmark. We've finally completed. Cisco, hopefully we're planning to complete soon. Huawei, we need to get an ETA on completion. And then Arista, we haven't made any progress. So we're going to remove Arista from the draft. Next slide. So here's just details on the status of testing. So Juniper is 100%, Nokia is 100%, and then really Cisco is in the third one that we're waiting on. We'll see what status we have on Huawei, but I think once Cisco is completed, I think we'll be ready for work group last call. Next slide. So this one I wanted to talk about a little bit more in detail. So the concept, so there were 5 SAFIs, and I went through all the SAFIs that exist today, and just to see if there weren't any missing. So from Jorge's email that he had related to the BGP Yang model, so we have MCAS VPN, and MCAS VPLS, EVPN, and BGPLS, and then CAR. So those are really the 5 SAFI types, NLRI, that use the concept of types. So when you're using the concept of types, and then how that relates to this draft is that when you have a type SAFI, basically the type, because you have a write type, and then the data field is actually it's not carried directly in the NLRI. It's part of a data field, enclosed underneath the route type. What ends up happening is, let's say if you have IPv4 and IPv6 NLRI, that is part of that's in the data field underneath the route type. So what that does is it kind of makes those route types that are type savvy, it makes them data plane agnostic. So in this draft, this is like it's an alternative to traditional dual stacking where you have a single, when you have inline control plane and data plane, and you have a single 4-peer or a single 6-peer, but it's carrying your V4 and V6 NLRI together on a single peer. So when you do that, it allows you to eliminate having that other address space, so the other protocol. So if it's a V6 peer, if it's a V6 peering, IPv6 only PE, you don't have a V4 address. And similarly, if it's an IPv4 only PE, you don't have a V6 address. So it's got that data plane construct. But when you have a typed SAFI, because it's typed and you have the data, the data is carried in a separate, it's carried underneath the NLRI, not directly in the NLRI. And a good example is, let's say, L3 VPN. It's carried directly. So then because it's carried directly in the NLRI and not underneath the route type, it's data plane dependent. And because of that, that really makes these SAFIs not applicable to the IPv4 only PE or the IPv6 only PE. So that is an update that I'm planning to do after this call. Just wanted to review that with the work group to see if anyone has any comments or questions on that. But that's a big update. So I'll have that updated hopefully within the next day or so. Next slide. So this next update is related to SRv6 compression and just the applicability of that. So in this draft, we've been working individually with each of the vendors doing their testing on the IPv6 only PE design and the IPv6 only with a single V4 peer, single V6 peer. We've been doing it independently, each vendor. I am planning to have the testing actually also done at MPL's World Congress next year with Yantech. And that'll be really great for interop. As part of that, a big section of what's done at MPL's World Congress is they do have an SRv6 section. So what I try to do is actually incorporate how this draft is applicable and is it applicable to SRv6, the CSID, NextSID flavor. And so with that, there's four basically test cases that we're going to add to our testing. One is with global table, and it's the inter-AS piece when you're doing inter-AS PE to PE peering. And one is where SRv6 is enabled on the PEs. And then a second, and this is with global table. And then another one is where you're using, where the PE to PE peering, SRv6 is disabled, but here you're using the IP data plane to stitch. And that's one of the benefits of CSID is that you don't necessarily have to have SRv6 enabled on every node. And there could be portions of the network, especially even like the interdomain ties, they can be it could be just a vanilla IP data plane. So the global table with IPv6 disabled, and then the VPN is test number 3 is SRv6 enabled on the inter-AS peers, but then we have SRv6 enabled, and then we do the same test with SRv6 disabled, and that's where we're doing just the IP data plane is stitching the VPN overlay. Next slide. So we're planning to finish off testing. It's been a long road. I think that we've been, 3 or 4 years in the works, but we're hoping to be finished this fall, and then we'll plan for work group last call. Thank you.
Okay, any comments? Okay, we probably do need to have a discussion at some point on what we want to do with this draft around working group last call time. It's fairly unusual to publish an RFC with this much data in it of this nature.
Okay.
So there are obviously other avenues that the work could be published within the IETF, but we need to talk about what you want to do with that.
Okay.
Okay.
Okay. Thank you.
Thank you.
So it's red code still not available.
Ratko, are you still? Yeah, we have a few minutes. We have 5 minutes. Are you still not able to Get your mic working and your speaker working. I do not see anything on the chat. So he's gone. Okay, thank you very much, everyone. See you in Dublin.
Good that we had.
Sorry?
Good that we had.
Yeah. Didn't expect it. Well, because I think that's really